In this video, we're going to be using the compound interest formula to see how money grows when our interest is compounded. So as you can see here, I wrote out 3 years worth of compounding interest. So if our initial amount, which we call the principal amount, if I went to the bank and put in $1,000 and didn't ever add any more to it, and it gained a 5% rate of interest, I would end up with my $1,000 plus my $50 that I earned in interest. So for our second year, we take the principal plus the interest I gained, and then we apply that 5% rate of interest again. And as you can see, my money's growing here a lot faster than would the money grow with simple interest. So look here, for our third year, we take our principal plus the interest we gained that first year, then the interest we gained in our second year, and we again apply that 5% rate of interest, and here we end up with $1,157.63. So as you can see, money can grow very quickly if you have a good rate of interest. So let's go ahead and look at this formula here. This is what we'll use to solve for compound interest. So A is equal to our accumulated amount. Our P stands for our principal amount. Our R here on the top part of this fraction is our annual interest rate, and it's as a decimal. Interest rates are usually given in percents, but when we need to work out these problems mathematically, we use our decimal form of that percent. Then we have N, that's the number of times the interest is compounded per year, and then T is equal to the number of years. So let's go ahead and work out an example. So as you can see, this looks very similar to my formula, but I just plugged in our values for our variables. So for our principal initial amount, we're going to drop in the bank here for this example would be $1,500. So we're going to put that in there, and we're not going to add any more money to it, and we're going to have an 8% rate of interest. So remember, as I said earlier, 8%, when we convert to a decimal, we just bump a decimal over from the percent sign twice, and that gives us our 0.08. Okay, so that's going to go right here. That's our rate of interest. And then the N is going to be the number of times the interest is compounded per year. For our first example here, introducing compound interest, we're just going to say it's going to only compound once at the end of the year. Okay? And let's say it's for 20 years. So that's T. Okay, so let's go ahead and solve. Alright, so following our order of operations, I'm solving inside parentheses first, and we know that any number divided by 1 just gives us that same number again. So here it is right here. We did 800ths divided by 1, giving us our 800ths. Okay, so our next step was to add our 1 to our 800ths, giving us our 1.08 here. Okay, and so now we're working on our exponents up here, and I just multiplied our 1 times 20, giving us 20. Okay, so now we had to do 1 in 800ths to the 20th power, and this is not 1.08 times 20. This is 1.08 times 1.08 times 1.08, all the way out 20 times. And that leaves us with this 4-point long decimal number here. And now we can find out what our accumulated amount is. We're going to multiply this to our principal initial amount of 1,500. Alright, so we end up with an accumulated amount of $6,991.44. Okay, so as you can see, money can grow pretty quickly with compounding interest. We more than quadrupled our initial principal amount, almost $7,000 here. So compounding interest is a great thing to learn about, and it'll help you possibly become a millionaire. Thanks for watching. We'll see you next time.